learners, the topic is program phases. What are the phases of a program? So the program will have basically 3 phases, which are writing the program, compiling the program, and executing the program. Okay, so those are the 3 very important phases of a program. So yes, let's go. So the first one, you can see the program phases here. Write the program, compile the program, and run the program. So now, so the first one, the first phase, which is write the program. So here, even let's not worry about writing of the program now, but we need to understand, yeah, first of all, the program should be written. So how we can write the program? So first of all, we need to know the program features. We need to know what are the features we have and how it works, how they work. So we need to know the syntax and semantics of the each and every programming feature. So then, of course, if any problem is given to us, then of course we apply some logic there and then we write the program. So that is the basic content of this, writing the program or write the program. Okay. So yes, let's not worry how to write a program now. Okay. So, but now the first phase is writing the program, provided, yes, if you know the features, we can write the program. Done. Good. So yes, so of course we'll save this program as it is add here. You can see add here. It is, we can save this program as add.c, which will be saved in the hard disk, of course. Then the next phase is compiling the program. Very important phase. When we want to compile the program, when we want to compile this program, but why we compile the program actually? So why we need to compile the program? We need to compile the program for 2 very important reasons: are to check for syntax errors and to convert the user program into a machine code or binary code. Very important 2 phases. What is syntax errors? How the compiler checks for syntax errors? Let's go back. So see here, for example, void main is there. Void main. You can see the void main here. So there is void space main and opening parenthesis and closing parenthesis. And then we have an opening brace and then some statements of followed, of course, int n1, n2, some semicolon. Maybe, for example, now what is the syntax error means? Let's understand. The compiler, what it will do is it will divide into tokens. It will divide everything into tokens. Simply, let me just, so void is one thing, and a space, and then the main, and then opening brace and closing brace. So everything is divided, which is called parsing. So the compiler will divide all the tokens. So then it checks for maybe any spelling mistakes. For example, void spelling mistake. If I miss there is a vid instead of putting right void. If there is any spelling mistake, yes, it will stop saying that we can't understand the vid. So void spelling mistakes, it checks, and after void there should be a space. The syntax is void space main and then opening brace and opening parenthesis and closing parenthesis. Even if you forget the space in between void and main, yes, it gives an error. After the main, if you miss some parentheses there, maybe 1 or 2 also, we may forget. We may not be knowing also. So then it throws an error. It gives an error. So see, compiler checks for syntax errors. So void space main with the parenthesis and then opening brace. So if anything is missing, even followed by C, int n1 and some semicolon. Any statement in C language should end with a semicolon. Maybe if we miss the semicolon, then also it throws an error. Because it is a rule. It is a rule of the C programming. As we have been telling you, the syntax and semantics. So every statement should be like this. And the main should be like this. So the body should be like this. The body of the main function should be like this. Any error, any sort of lapse takes place here, maybe the spelling mistake, or if you forget some token or a symbol, then, or some rules like semicolons, then it gives an error called a syntax error. Nothing but if there is any mistake in the physical alignment of the tokens and the symbols, then it throws a syntax error. So first of all, during the compilation, the syntax errors will be checked. Syntax errors will be, of course, checked and informed to the user. User, these are the errors you have, please correct them. So then the user will, of course, go to line after line and where the errors are there, and of course, he'll correct the errors. And then if all the errors are clear, then the next phase is it converts that error-free program into a, of course, which is there in English statements, into a machine code or binary code. Machine code or binary code, both are same, of course. Okay. So this English statement, why? Because the processor can't understand English. It knows only two letters or two digits, which are 0 and 1. That's all. So that's the reason in the compilation, after checking the syntax errors, it converts the error-free this program add.c into add.exe or add.obj after checking the syntactical errors, after parsing all the tokens and symbols. Okay, so that is your compilation. So then add.c is converted into add.obj and add.exe after proper syntactical errors clearing, after clearing all the syntactical errors. Okay, that is your compilation phase. And then last one, running the program, run the program. So if everything is ready with add.c is converted to add.exe and add.obj, then so when we actually give the running command to execute the program, so then obviously the CPU, the processor, will execute the program. For example, let me just show you. So it executes from the main. The processor will start from this main function, executes line after line. It just goes line after line. Okay, so there is a function call here. From there, it just comes to this function definition. We'll see that later, of course. So from here again, it will perform all the things. Again, it will just come back. So once all the lines are over, of course, it just comes out of the program by just giving the output of the program. So this is the running the program or executing the program. So the CPU starts from the main function, executes line after line after line, and then maybe the control may jump from one line to another line. Okay, from 50 it may go to 75. See, from this function call, it has gone to this function definition here. From here it takes a jump, and again just perform all these things here, and again go back to this statement. So like that, the CPU, the processor, will execute line after line after line, taking the jumps here and there, and again come back to the same place, and then complete all the lines. Once all the lines are over, then it just comes out of the program by just giving the output of the program. So like this. So we write the program, and then we compile the program, and then we run the program, and we get the final output of the program. Hope you've understood. Thank you.